Morning students, this video is the continuation of what we have discussed before. The present running chapter is differential equations, and I request you, before watching this video, please watch the two lectures that we have uploaded before. So let us continue from where we have stopped the previous lecture. So the third Roman is what it is continuing. So this is y is equals to ax square plus bx a comma b. So this is the second problem. So y is equals to ax square plus bx, and we need to eliminate the constants a and b. So for which it is obvious, which we have discussed before also. So to form the differential equation, since it contains two arbitrary constants, in other words parameters also we can say. So since it contains two arbitrary constants for which we need to differentiate it twice. So differentiating with respect to x once, then dy by dx, or simply we can write it as y dash also, is equals to 2ax plus b. Y dash is equals to 2ax plus b. So from this, again differentiating with respect to x, now this time y double dash. Y with respect to x is dy by dx, y dash also we can denote, and y dash is dy by dx. If we differentiate it for this dy by dx, we will be getting d square by dx square, which is also represented by y double dash. Now what is 2ax derivative? 2a into dy by dx of x is 1, 2a into 1 is 2. So b is a pure constant which is free from any variable. So y dash is equals to 2a. So substituting y double dash in, substituting 2a in y dash, we get y dash is equals to 2a is y double dash. 2a is y double dash into x plus b. From this, the value of, because a and b are the arbitrary constants, therefore we need to prepare a and b here. So this is y dash minus y double dash x is equals to b. This is b, and from this a is equals to y double dash by 2. Substituting a comma b values in y, we will get y is equals to, the value of a is y double dash by 2 into x square, plus b value is y dash minus y double dash x into x. This is 2y is equals to y double dash x square plus 2 into x into y dash minus 2 into x square. This is y double dash. Now, so y double dash x square minus 2x square y double dash is equals to minus x square y double dash plus 2xy dash is equals to 2y. So if we replace y double dash by d square by dx square and y dash by dy by dx, then we will be getting x square d square y by dx square minus 2x y dash is dy by dx. All these terms I am transposing onto this side, plus 2y is equals to 0 is the required differential equation. Now, the third one is y is equals to ax square plus by square is equals to 1. Ax square plus by square equals to 1. So here we have to eliminate the parameters a and b. So obviously we have to differentiate it twice. So differentiating with respect to x on both sides. This is a x square derivative is 2x plus b y square derivative is 2y. Suppose y square na, so y you just treat it as x square derivative is 2x into, since we have taken treated y to be x, we need to differentiate it later, which is dy dx of y is dy by dx is equals to, the value of 1 is 0. The derivative of 1 is 0. If you take 2 as a common, then we get ax plus by dy by dx is equals to 0. Therefore, ax plus by dy by dx is equals to 0. From this, b by dy by dx is equals to minus ax. So from this, dy by dx into, this is y by x, dy by dx is equals to minus a by b. So let us suppose this to be y by x into dy by dx is y dash is equals to minus a by b. Again differentiating, we get, so this is y dash by x, this is u by v. So v u dash, that is d by dx of this, that means y dash whole dash minus y dash into d by dx of x is 1 by x square. Here this is x because v u dash minus u v dash by v square is equals to, the constant derivative is 0 here. Now this is equals to x, this is again uv dash, uv whole dash, uv dash plus vu dash. So y dash derivative is y double dash plus y dash into d by dx of y is dy by dx, that is into another y dash whole square minus, this is again I'm telling you, y into y dash derivative is y double dash, u v dash is over, plus v u dash, keeping y dash intact, d by dx of y, the derivative of y is y dash into y dash square minus, this is y dash, this is equals to x square into 0 cross multiplication 0. Therefore this is x y dash is d square y by dx square. Next step, plus x y dash value is dy by dx, it has a square here, minus y into, what is the value of y dash, dy by dx is equals to 0. So this is the required differential equation we are looking for. The next question is the fourth bit from third Roman first question. xy is equals to ax square plus b by x. So here we need to eliminate a comma b values. Let us cross multiply this. So this is x square y is equals to ax cube plus b. What I am doing is x, I have taken an LCM and I just transposed onto the other side. So by x is the LCM. So ax cube plus b. This by x, if you transpose onto the other side, x into x square y. So now differentiating with respect to x on both sides. So before that, so now differentiating with respect to x on both sides. This is equals to x square into d by dx of y is dy by dx, that is y dash, plus y into d by dx of x square is 2x is equals to a constant, x cube derivative is 3x square plus d by dx of b constant derivative is 0. Therefore we get a x square y dash plus 2xy is equals to 3ax square. Now let us divide with x square on both sides. Dividing by x square on both sides. Then x square y dash plus 2xy by x square. X square gets cancelled. We are left with y dash plus 2xy by x square. This is 2y by x. Because 2xy by x square. X gets cancelled. 2y by x. This is equals to 3a. Dividing by x square gets cancelled. We are left with 3a. So now, so far we have differentiated once, but here the equation contains two arbitrary constants. Therefore, one more time we have to differentiate. Again differentiating, we get, so this is y dash derivative is y double dash plus 2 into, this is y by x, u by v, v u dash minus u v dash by v square. This is x into d by dx of y is dy by dx, that is y dash, minus y into d by dx of x is 1. This is so far v u dash minus u v dash by now v square, x means x square. So 3a is a pure constant which is free from any variable, therefore it is a constant. Constant's derivative is 0. Now if you take the LCM, then x square y double dash plus 2x y dash minus 2y is equals to 0. Therefore x square into what is y double dash? Y double dash is the second order derivative, d square y by dx square by plus 2x. What is y dash? Differentiating y with respect to x, then we get dy by dx. That is the first order derivative, dy by dx minus 2y equals to 0 is the required differential equation. Obtain the differential equation which corresponds to each of the following family of curves, the circles which touch the y-axis at the origin. The difference between this problem with that of the last problem is, as far as the last problem was concerned, the equation has been directly given. But as far as this is concerned, this is a word problem, some information has been given. Based on that information, first we need to obtain the equation of the family of all the curves. Then actually we will get the equation, and that equation we need to differentiate. So obviously if the equation contains one parameter or arbitrary constant, we need to differentiate it once. If it contains two, accordingly actually we need to differentiate it twice. And if we get n number of constants or parameters, then we need to differentiate it n number of times. Okay, now so the circles which touches the y-axis at the origin. So this is the data given. So that means he is asking all the circles which touches the y-axis at the origin. See this. This we have discussed in the circles chapter. So this is the circle. This circle we want, and this circle is passing through the origin O. So this circle clearly it is seemed to be touching the y-axis. You may ask a question, why can't this circle touches y-axis on the other side also? Yes, we can. So this can also be the one. Okay, this is also the circle passing through the origin. And not only this, actually the n number of infinite number of circles we can have following the condition which touches the y-axis and passing through the origin. Not only that, so actually if you take this circle also for the consideration, so this is also one circle likewise. So now one thing is clear, that since the y-axis is acting like a tangent, so what is the line? Y-axis is acting like a tangent. So the line which is perpendicular to this tangent is what? It's a normal. This is a y-axis. Okay. So this is a line which touches the circle at only one point, which is an origin. This is called the y-axis is called the tangent, and the perpendicular which is the and the perpendicular to this tangent is what? It's a normal. And if y-axis is a tangent, the normal is x-axis. So in the property of circles, we have learned that normal always passing through the center of the circle. So therefore this is the center. So this is the normal. If I take the circle to be the general equation of the circle, x square plus y square plus 2gx plus 2fy plus c equals to 0 is this circle. Since this circle is passing through the center of the circle, since this circle is passing through the center, since this circle is passing through the origin, okay, so that means c is equals to 0. And if it is the equation of the circle, its center is minus g comma, what is the center of this? Minus g comma minus f. And what is the radius of this? R is equals to square root of g square plus f square minus c. Now, since the center lies on x-axis, and this normal which is perpendicular to this tangent, and this normal is x-axis, any point on the x-axis y coordinate is 0. So minus g comma, this is 0. And see here f is 0, c is obviously 0 because it is passing through the origin. That means x square plus y square plus 2gx plus 2fy plus c equals to 0. If we substitute 0, 0 here, 0, 0, 0, so c is equals to 0. If you substitute c is equals to 0 back in this, then x square plus y square plus 2gx plus 2fy equals to 0. Okay. Now, c is 0. On x-axis, y coordinate is 0. Okay. This is also 0. That means r is equals to g. What is r? R is g. G is a modulus because the circle may be on the other side of this y-axis as well. Therefore, modulus of g I will take. What is our modulus of g? So therefore, I have center C is equals to minus g comma 0 at radius g. So with this, what is the equation of the circle now? So center C is minus g comma 0 and radius is equals to modulus of g. So center, it will be minus g comma 0. If the circle is based on this, it will be plus or minus g comma 0. Therefore, equation of all circles, which touches x-axis, which touch y-axis at the origin is so y minus 0, so h comma k and radius r. So equation of a circle in its central form having center C, h comma k and radius r is x minus plus or minus g whole square plus y minus 0 whole square is equals to r square, so g square. This is equals to x square plus g square plus 2gx plus y square is equals to g square. So g square gets cancelled. Therefore, x square plus y square plus 2gx is equals to 0 is the equation given. So this is not the answer. So our solution will start from this step onwards. Actually, so far the last problems are concerned, actually this equation he has given directly, but this equation we had to obtain by the given data. So now here g is the only parameter for which we need to differentiate it once, and if it is not eliminated by the suitable substitutions, we need to eliminate this value of g. Now differentiating with respect to x once, this is x square derivative is 2x, y square derivative is 2y, dy by dx, 2g, dy by dx of x is 1 is equals to 0. If you take 2 as a common and transpose on to other side, 0 by 2 0. So directly I have cancelled like this. Now y dy by dx, x plus y dy by dx is equals to minus g, or g is equals to minus of this. Now substituting g in equation 1, then x square plus y square plus 2x into, what is the value of g here? Minus of x plus y dy by dx. This is equals to 0. This is equals to x square plus y square plus into minus 2x into x square plus into minus 2xy dy by dx is equals to 0. This is equals to y square plus x square minus 2x square is minus x square minus 2xy dy by dx is equals to 0. This is the required differential equation, corresponds to all the family of circles which touches y-axis at the origin. The parabolas, each of which has a latus rectum 4a and whose axes are parallel to x-axis. So this is the problem from the parabolas. So prior to this, I request you to watch my videos on the lecture parabola chapter, where I have clearly discussed all the various forms of parabolas. So now the parabolas, each of which has a latus rectum 4a and axes are parallel to x-axis. So the parabolas corresponds to the given data is of the form y minus k whole square is equals to 4a into x minus h. So this is the parabola. This is the parabola which is parallel to x-axis and has the latus rectum 4a. I'll tell you. See, this is the parabola. Y power even symmetric about x-axis. So this is my chord axis, and this is O, origin 0, 0. This is negative x-axis, positive x-axis, negative y-axis, positive y-axis, and this coordinate axis has been shifted to O dash. This is h comma k. So without changing the actual direction of the coordinate axis, a new axis has formed now. This is capital X X dash, and this is capital Y Y dash, and this is the focus, and this is the latus rectum. Latus rectum is the chord passing through the focus and perpendicular to the principal axis. So this is 4a, that is given in the question. Latus rectum is 4a and axis parallel to x-axis. So what is meant by axis? Axis is nothing but a straight line passing through the fixed point. Here the fixed point is S, a comma 0. So a plus h comma k. So passing through the fixed point and perpendicular to the directrix. This is the fixed line called directrix, and this line not only perpendicular to the fixed line. This line not only perpendicular to the fixed line, but also this line passing through the fixed point, which is focus. So the equation corresponds to the given data is y minus k whole square equals to 4a into x minus h. Now here the latus rectum is 4a and the axis means, so the line axis means the line passing through the focus. Here this line is the principal axis and this line is parallel to the x-axis. Capital XX dash is parallel to small xx dash. So therefore y minus k whole square is equals to 4a into x minus h. So this is the equation given here. Y, x are the variables, k, h are the parameters. A is not a parameter here, it is a constant. Okay, so parameter and arbitrary constants are synonyms, but here a is a constant. Here h comma k are what we need to eliminate. Therefore there are two parameters here for which we need to differentiate it twice. So differentiating with respect to x once. Now suppose this to be x square derivative is 2x. So 2 y minus k into, so we need to differentiate it later. So d by dx of this is dy by dx is equals to 4a into d by dx of x minus h is 1. So this is 2 times. Therefore y minus k into y dash is equals to 2a. Therefore, this is from this. y minus k is equals to 2a by y dash. So now again differentiating. Otherwise you keep the same here. Now again differentiating, we get, so y minus k into y dash derivative is y double dash plus y dash into y minus k derivative is y dash is equals to 2a derivative is 0. But here y minus k is not eliminated, but actually we can write y minus k to be 2a by y dash. Now replacing y minus k with this 2a by y dash and substituting this, then we will get the required differential equation. Substituting 2a by y dash in y minus k, we get k in the above equation. We get y minus k is 2a by y dash into y double dash plus y dash square is equals to 0. Therefore this is 2a y double dash plus y dash into y dash square. So y dash cube equals to 0. Now 2a, what is y double dash? This is d square y by dx square plus what is y dash? dy by dx whole cube is equals to 0 is the required differential equation. So the parabolas having their foci at the origin and axis along the x-axis. So this is the last problem from the 8-day exercise. Now here what has been given is, so if you are not familiar with this parabola, I have made a playlist by name Parabola where I have clearly explained all the various forms of parabolas. So you can go and watch the videos once for better understanding. Now let us see this. The parabola is said to be in its standard or simplest form if and only if the vertex is at the origin. So for example, if you consider, so axis is along x-axis, that is symmetric about x-axis. Symmetric about x-axis, y square equals to 4ax or y square equals to minus 4ax. See here. So this is the y square equals to 4x parabola. So here this x-axis is acting like a symmetric about this parabola. So now, so this is vertex A is 0, 0. Here S is A comma 0. And this is the directrix L equals to 0. This is Z, which is minus A comma 0. So therefore the equation of this parabola is y square equals to 4ax. Y square equals to 4ax, where what is this 4a? This is the L dash. So this is the length of the latus rectum. Now the parabola having their foci at the origin. So the same parabola, I am writing it again. So this time the focus is at the origin. Foci. Sir, why foci has been mentioned? There are parabolas like what I am going to discuss here, I will tell. So focus at the origin. So this is the origin and the focus is right here itself. Focus is at the origin. So that means now the parabola is this. Now the parabola is this. And same at origin the focus is located is what the question given. Now this is equals to, now this is the vertex now. So this is 0, 0. This is minus a comma 0 because this is situated or located on the right hand, left hand side of x-axis. So negative coordinate, negative x-axis. Therefore, this is minus a comma 0. Therefore, this is h comma k. This is h comma k. Vertex is h comma k. It will be y minus 0 whole square is equals to 4a into x minus of minus x plus a. Now I will come to the point. See this same thing. This is my origin here. So this is S and the parabola could be like this also. So the parabola could be like this also, right? So still the focus is at the origin only, but it is still the x-axis is still symmetric about x-axis. The axis is along x-axis. So the parabola could be like this also. Now this is 0, 0. So now the vertex is situated on the right hand side of the y-axis. It is on the y-axis, on the x-axis. On the x-axis, y coordinate is 0. Therefore, this is a comma 0. In this here, in this, it will be y minus 0 whole square is equals to 4a into x minus a. Then this is y square is equals to 4a into x plus or minus a. That is why the focus will be here or will be here. If the parabola is this, then if the focus is here, the parabola is symmetric about x-axis. Axis is along x-axis. Otherwise, the same situation, the parabola could be like this as well. Therefore, y square is equals to 4a into x plus a. This is the question given. Now, since here it contains the only one constant which is a, so y square is equals to 4a into x plus a. So this is the given equation of the family of all parabolas whose foci at the origin and axis along x-axis. Now, since it is having the only parameter or arbitrary constant for which we need to differentiate it only once. So y square derivative is 2y dy by dx is equals to 4a into x plus a. So this is 1. So this is 2 times. So therefore this is y by 2 dy by dx is equals to a. Y by 2 dy by dx is equals to a. Substituting a in y square equals to 4a into x plus a. So this is equals to y square is equals to 4 into the value of a is this. The value of a is y by 2 dy by dx into x plus the value of a is y by 2 dy by dx. So this is equals to, cancel this in 2 times. So y square is equals to 2y dy by dx. Y square equals to 2y dy by dx into 2x plus y 2x plus y dy by dx by 2. So if you cancel y throughout the equation, this as well as this gets cancelled. and this 2 and this 2 will be cancelled. Therefore, we are left with y is equals to this is 2x dy by dx, 2x dy by dx, 2x dy by dx plus y dy by dx into dy by dx, dy by dx whole square. Therefore, the equation of the required differential equation is y dy by dx whole square plus 2x dy by dx minus y equals to 0.